start with this one. Let's start with this one, and then from there we can see on how far we go. We start with 5x minus 3. Let's try to draw that 5x minus 3 and see how far we go. But remember, today's lesson, our main focus is the parabola. Since last time we've been talking about the straight line, so today's lesson we're going to focus on the parabola. But before we go to parabola, let's try to remember to answer this. Remember, the format of this graph, a straight line graph, is y is equals to m, which is the gradient, x plus c, and the c will always be the constant. And I said and I repeat, for you to draw this graph, you need to use this formula: y minus y1 is equals to m into x minus x1. I don't have a problem if you use this formula. You can use that. My only problem is that learners leave the answer as c is equals to something, and they just leave it there. But the question is not asking that. The question is asking for something like that. Then you end up losing marks just because when you left the answer at c. Why do I prefer this one? Because this one, you can never leave it as c is equals to something. The answer will always be y is equals to something. Why am I saying that? Because you're going to substitute the value of y1, you're going to substitute the gradient, you're going to substitute x1 for you to get the equation of a line. Remember what I said in Euclidean, analytical geometry. Even now I'm still saying, for you to calculate or to get the equation of a straight line, you need two things. You need the gradient, and you also need at least 1 point. If you've got more than 1 point, you are more than enough. That's okay. But now, what if the question, they gave you the equation? So you can't say, let me calculate the equation, because the equation is already given to you. You are given the equation. If you are given the equation, it means they are going to say draw. Sometimes they will draw the graph for you. We're still going to move to those questions whereby the graph is drawn for you. For now, let's say they gave you the equation y is equals to 5x minus 3. And they say draw the graph. What do you need? You need the x-intercept. You also need the y-intercept. For you to get the x-intercept, you need to say in space of y, let there be 0. And then for you to get the y-intercept, you need to say in space of x, you need to say in space of x, let there be 0. So if you are looking for the x-intercept, like I did explain last time, guys, let me use this one. On the y-axis, the value of x is 0. On the x-axis, the value of y is 0. Now, if I'm saying find the x-intercept, it means I'm saying find the value of x on the x-axis. And we know on the x-axis, the value of y is 0. That's why I'm saying let y equals to 0. If I'm saying find the y-intercept, I'm trying to say find the value of y on the y-axis. And that means the value of y on the y-axis, the value of x on the y-axis is 0. That's why I'm saying let that be 0 in space of x. So what do? You take the same equation that is given to you. The same equation that is given to you. That is y is equals to 5x minus 3. What do you do with this equation? Wherever you see y, you put 0 so that you can get x. In this side, you also do the same thing. Y is equals to 5x minus 3. What do you do? Because you're looking for y, where you see x, you put 0. Let's start with this one of looking for y. It's always the easiest. Always the easiest. I'm going to remove x. And when you got x in the space of x, tulong x kibe among 0. I put 0 in space of x. Then you guys can press your calculator. You get y is equals to how much? What is the value of y? I'm waiting for the answer. How much?
2.
Okay, I wanted to press the calculator again just to double check exactly as I've written.
Says it negative 3, sir.
How much?
Negative 3, sir.
Okay, thank you, thank you. Negative 3. Okay, it means if I write this in coordinates form, my x is 0, like we said there. We said x is 0. So my x is 0, and then my y at this point, my y is equals to negative 3. Guys, it's always easy to get y. And I explained last time that y, even without calculating, if I put y x equals to 0, y automatically becomes c. So every time you see the c, you can say c is the value of y. Just looking at this, you can say my c is negative 3. So negative 3 is y. Just there, without calculations. But if you feel like you don't understand, just calculate. Just calculate, no problem. Okay, let's use this one and look for the x. If we're looking for x, wherever we see y, we put 0. So I'm gonna put remove y, and then in space of y, I'm going to put what? 0. Then I can transpose and solve for x. Let's transpose 3. Well, then we're going to have positive 3 because it's negative. When we transpose, it becomes positive. Positive 3 is equals to 5x. Then what is my next step from here? Someone who can help me very fast. What is my next step?
I think you divide
Okay,
by 3,
divide
sir.
by 5. Divide by 5. If I do divide by 5 both sides, then I'm going to be left with x this side. X is equals to how much? 3 over 5. If I'm right, 3 over 5 is 0 comma something something. What is 0 comma what?
0,6.
Okay, 0 comma 6. 0 comma 6. Okay. Guys, the first day I explained, you can write those numbers 1, 2, 3, 4, 5, negative. You can write all those numbers. But as long as you know in quadrant 1 x unjani, in quadrant 2 x unjani, in quadrant 3 x unjani, quadrant 4 x unjani, just like that, like that, like that. If you know in which quadrant is x positive, in which quadrant is y positive, then this thing is easy. From here, let's just go and place positive 3 over 5. Is it in this quadrant? That is number 1. Or is in this quadrant, number 2? So where do I put positive 3 over 5? Do I put it in number 1 or in number 2?
Number 2, sir.
Thank you. Because in that quadrant, x is positive. So I can choose anywhere. I can choose anywhere. Because I don't want to write numbers so that they can confuse me. But you guys, I know you'll write numbers because you'll be using rulers. Myself, I'm not using a ruler here, so I don't want to confuse myself. Okay, so I'm going to say that point is 3 over 5. Someone will be like, 0 comma ngibeka kanje. Wawungabeki 1 lana. No. It's the same, guys. The same. Since I didn't write numbers, I can put it anywhere. I can put it anywhere. Okay. And then we also said y is negative 3. Y is negative 3 in this side, number 1, or y is negative 3 in this side, number 2. Where is y negative 3? Is it on number 1 or on number 2?
Number 2.
Okay, on number 2. On number 2, that is the side whereby you're going to get y is equals to negative. Y is equals to negative. So I'm gonna put negative 2 somewhere there. Negative 3, sorry. Negative 3. Then my negative 3 will be there. Then I can draw my straight line. My straight line will have to touch there, and then will also touch there, and then like that. Wow, it's not very straight, by the way. Let me try for the last time. Hi iPhone. Was trying to make it straight. My straight line is not straight, but I'm trying. I tried To me, it looks like a straight line. I hope it also looks like a straight line to you. Does it look like a straight line to someone? Yes, no. I tried my
Yes, sir.
I tried my best. Okay. Then all of you have drawn, and then even though some of you I couldn't see clearly what you've drawn, did any of you draw something like that? Who did? Any of you have drawn something like that? Wow, no one. Okay. Can I talk about the domain and the range? Can I talk about the domain and also talk about the range? Okay, the domain. When I talk about the domain, I'm talking about the starting point and the end point on the graph, but looking at the x values. I'm looking at the x values. Where does the graph start on the x-axis? Where does the graph start on the x-axis? Where does it end on the x-axis? Remember, let me do this to help someone to understand better. This graph, because I did put arrows, I'm just showing you to say this graph can be extended to say the graph is going that way, and the very same graph that I'm talking about is going that way. So the question is, where it is going this side on the x-axis, where does it end or where does it start? Where it's going this side, where does it end or where does it start? Basically, immediately we put the arrows like that. It means it's gonna go on and on and on and on and on forever and ever. Amen. We don't know where is it going to start. We don't know where is it going to end. Meaning, we are talking about all the values of x from negative infinity and all the value of x to positive infinity. So, all the values of x on this line, all of them from the negative numbers up until the positive numbers, the graph is existing. Oh, what am I doing? I'm messing up my drawings now. The graph is existing. There's a graph. There's a graph. There's a graph. If you check, x ukhona lana on this graph, on this point, and then no y naye ukhona at this point. So I can know this point. I can still know this point because all the values of x are there and all the values of y are there. Now, allow me to say the graph can start at negative infinity and then it's gonna end at positive infinity. So I'll say x is the element of positive in negative infinity up to positive infinity. But myself, guys, for domain, I just left this one. I just write x is the element of real numbers, meaning I'm including all the positive and negative values. Can I use or here? Okay, I don't usually prefer to write like this. Yes, it's from negative infinity to positive infinity, but I just include all the values by saying x is the element of real numbers. If you check y, the graph is existing at any point on this line. Why am I saying it's existing? X and y, they are there. And as I'm going on, at any point, if I draw the graph like that, at any point, there is x and there is y here, and it does exist. So it's just that I didn't draw the graph up to that point. I can draw the graph to anywhere. So I'm including both the x and the y. X and y. Okay, I made a mistake there. I'm including both x values and y values, and they are there in every side. So the range of this graph will also be y is the element of real numbers. Or you can write y starts from negative infinity up to positive infinity. Myself, I just prefer this. X is the element of real numbers, y is the element of real numbers. X is the domain, y is the range. I'm going to talk about the domain and the range in all the graphs. Just remember, ku X, my focus is the domain, ku Y, my focus is the range. So there is my graph there. I've drawn the graph. I'm going to come to the point whereby I'm going to say draw the two graphs on the same set of axes. For me, just to double check if you guys did understand what I did last time when we were together, is this graph decreasing or it's increasing? Anyone? Someone will be saying it's decreasing. Is it increasing or is decreasing? Hello?
I think it's increasing, sir.
It is increasing. Because every time we write, guys, we start from the left hand side. So if you are going to say kodwa le graph inje, yes, inje will write when I started on the right hand side. Just say inje, but remembering that we always start on the left hand side going to the right hand side, meaning if I have to draw this graph and start on the left hand side, I'm going to increase. If I start, I'm going to increase. I'm going up. So the graph is increasing. Why is the graph increasing? If I may ask someone who remembers, why is the graph increasing? Anyone? We did talk about that here.
Isn't it, sir, because something like the gradient is something, I don't know, sir.
Thank you. It is increasing because the gradient is positive. The increasing because the gradient is positive. I believe people didn't check these notes because we did talk about that. And even there on the online class, I mean, if you check the link that I've sent you, this thing is there. We ended there. So I did explain the decrease and the increase because I asked that question when we were doing this. Someone said, yes, I can see it's increasing, I can see. And I said, why? Someone said it's because of the gradient. And I reminded you because we were doing analytical geometry. The gradient is talking about the slope, either going down the hill or up the hill. And I emphasized that here to say the graph is decreasing if our m, which is the gradient, is negative. The graph is increasing if our gradient, which is m, is greater than 0 or it is positive. Okay. I also gave another homework. Oh, we did this. And I gave another homework. And I said, go and draw this graph. Guys, when I give you work to do it. I said draw this graph. Y is equals to x squared minus 9. We do the same thing we did up there. But for this one, can we start with the basics? Because I remember this graph, it was just because of time, then I didn't start or go deeper into the basics. We do the same thing. If we're looking for the x-intercept, we let y to be 0. If we're looking for the y-intercept, we let x to be 0. But remember, this graph is called a parabola graph. Or they say it's quadratic. Preferably, I prefer to use parabola. Okay. And then the parabola graph has got this shape, either facing up or facing down. It's either facing up, and then people would say it is smiling. I don't know if it's smiling or what, but I just know that it's facing up, or facing down. When is the graph facing up or is facing down? Now remember, the basic graph is y is equals to ax squared plus b. Ax squared plus b. Remember, I can use any variables, by the way. I can use any variables. But now, let's focus on ax squared plus b. A is the coefficient of x squared, b is the constant. In grade 11, you're going to draw y is equals to ax squared plus bx plus c. You're going to draw that one in grade 11. And then we'll be talking about the turning point. We'll be talking about the turning point in grade 11. In grade 10, the turning point is there, but it's very easy to get. Very easy to get. Now, for now, let's talk about this. When is the graph facing up? It's facing up if our A is positive. If our A is positive, the graph will face up. It's facing down if our A is negative, that is smaller than 0, or A is negative. If the graph is facing up, is because A is positive. If the graph is facing down, is because A is negative. Now, I said draw the graph. We are still going to talk about the domain in the range here. We are going to talk about the domain in the range. But before we do that, let's talk about this graph. X squared, okay, y is equals to x squared minus 9. Y is equals to x squared minus 9. This graph has got two x values. Remember, we can use this table here, x, y, and then negative 2, negative 1, 0, 1, and then 2. When you are alone at home, can you please redraw this graph? The very same graph that I'm talking about. Can you just redraw this graph using this table and check if we are going to get the same thing that we are going to get together now? Now, what we usually do here, like I said, if we are looking for y, we let x to be 0. Y intercept. And then this one would be the x-intercept for this graph. If I'm looking for the y-intercept, someone who can remember, if I'm looking for y-intercept, what must I do? Remind me, please. If I'm looking for y-intercept, what must I do?
Let x be 0.
Thank you. It means I'm going to say, because I'm looking for the y-intercept, can I just do this for the sake of space, guys? And just do this for the sake of space. And then if I'm looking for the y-intercept, I'm going to say in space of x, let there be 0. If I'm looking for the x-intercept in space of y, let there be 0. Okay, let me just use the word let me just that. But even if I didn't use it, doesn't make a difference. Okay, now remember, I'm saying this because I explained that on the x-axis, y is 0. On the y-axis, x is 0. That is what I explained. Now, this is the graph that we have. Y is equals to x squared minus 9. And I'm looking for y. So what must I do to x? I'm going to x, remove x. Where there was x, then I'm putting what? 0. Then I've got y equals to 0 squared minus 9. And then my answer would be how much? I'm waiting for someone to answer me.
Negative 9, sir.
Negative 9. Then if I write my coordinates, the value of x is 0, but the value of y is negative 9. Let's talk about this side. X-intercept. If I'm looking for the x-intercept, I've got y is equals to x squared minus 9. What do? In space of y, I put 0. So I'm going to remove y. Wherever there was y, then I put how much? 0. 0. Then I can transpose and then work it out. If I transpose, or factorize, by the way, you can factorize, because if you factorize this difference of two squares, or you can transpose and put the square root both sides, it's still up to you. Remember, when you put the square root, you'll get two answers. That is a plus or a minus. Now, If I factorize, then I'm gonna open two brackets there, equals to 0. And then what is going to be my factors? Factors of x squared is what and what?
X and X.
Thank you. X and x. And then I know that the way you were taught in grade 9 to factorize the difference of two squares, they said find the square root of both numbers. So what would be the square root of 9?
3, sir.
So I'll put 3 there, and I'll also put 3 there. And then what will be the signs?
Positive and negative, sir.
Plus and minus. Then you can say x plus 3 equals to 0, or x minus 3 equals to 0. Then I've got x is equals to how much on the first one? Talk to me.
Negative 3.
Negative 3. And the second one, x will be equals to how much?
Positive 3.
Positive 3. So the coordinates here will be x is negative 3, but y is 0. And then the second one, x is equals to, what am I doing? The second one would be x is 3, but y is 0. Now I can go and draw the graph. Because I've got the x values and the y values. I've got the x values and the y values. So if I draw the graph, I'm going to have something like that. That is my Cartesian plane. Remember, you can write the numbers 1, 2, 3, 4, negative 1, negative 2. You can write those numbers. You can do that. Please, it's up to you. Myself, I'm just going to say, let's use the numbers that we have, the one numbers that we're looking for. We are looking for only 3 numbers. We are looking for the positive 3. We are looking for negative 3. We are also looking for negative 9. If I may ask, is this graph y is equals to x squared minus 9 going to face up or is going to face down? Mind you guys, if I'm not getting the answer, that is the time whereby I will be just remaining waiting.
It's going to face up, sir.
Face up. Why are we saying it's going to face up? Why should it face up? Why not down? Okay.
Sir, because we start at the left, sir.
Yes, we start at the left, I agree. But what is the other reason? The other reason is what I explained here.
Sir, isn't it because it's positive, sir?
What is positive? Yes, it's positive. But what is positive?
The gradient, sir.
Yes, the gradient. I prefer to use A here instead of saying the gradient. A is positive. I explained that, guys. A is positive. If A is positive, the graph will face up. Now, if I may ask here, what is the coefficient of x squared here? Looking at y equals to x squared minus 9. What is the coefficient of x squared? That is what I'm talking about there. I believe people can see that. Let me use the highlighter so that everyone can see. I'm talking about that. What is the coefficient of x squared? Remember, a coefficient is a number in front of the variable. I think I explained that part many times. A coefficient is a number in front of the variable. I'm talking about the variable x squared. The variable x there. What is the coefficient of that? I'm still waiting for the answer, by the way. Anyone to try? The coefficient of x squared? Yes, Kwanda?
I think it's 0.
Kwanda says the coefficient of x squared is 0. Rulani, the coefficient of x squared?
Sir, I think it's 1.
Okay, Zwanga says 1, Kwanda says 0. Now I'm a little bit confused. Rulani, the coefficient of x squared.
Yo, say, I'm not sure, say.
Okay. Libenya, the coefficient of x squared.
I'm not sure, say, but I think I agree with Kwanda.
Okay. Ntando, the coefficient of x squared. Just say something, Ntando, so that I can be sure that you are not offline, you're still there.
Say, I'm not sure.
Okay, thank you.
So you're asking on the y-intercept or
What,
x-intercept?
what I highlighted in green. I'm asking
Oh,
what I highlighted in green. I'm looking for the coefficient of x squared. Guys, let's remind each other here. I know you know, but let's just remind each other here. If I write for you 2x raised to 4, which one is the coefficient, which one is the base, which one is the variable, which one is the constant, which one is the exponent? Anything that you can know, just tell me. Tell 2, what is
4
2
is
to
the
you?
exponent.
4 is the exponent. Yes, I agree.
4 is the base. The exponent, man, sir.
Yes, 4 is the exponent. I agree. What else?
So isn't it 2 the constant?
Yes, it's a constant. Even 4 is the constant. But what is another way of saying 2? Because yes, it's a constant, but because where it's situated, what is it? Because of where it's situated.
Isn't
The
it said x a coefficient, sir?
coefficient. Coefficient is a number in front of the variable. Coefficient. Now, going back to this, what is the coefficient of this thing? What is the number in front of that thing? Yeah. I usually
One, sir.
yes, I usually emphasize in grade 9 to say, guys, if I write x and I'm saying what is the coefficient, I usually tell them to say the answer they must say is an invisible one. Invisible one. And I'm saying what is the exponent, I usually tell them they must never say the exponent is 0. They must say the exponent is invisible 1. So if I write x raised to 2 and I'm asking what is the coefficient, it means there is an invisible 1 here, which is the coefficient. The coefficient is positive 1. For the fact that it is positive, for the fact that it is positive, it forces the graph to face up. I said go and use a table to check if you can get the same drawing that we're going to have. So because the coefficient is positive, then we are going to have something like that. The graph will face up. There is our graph there. But now, this graph, if we check, I can still expand it. Let me use another colors. I can still expand it and say I'm drawing the very same graph, but I'm gonna draw it like that. It's still touching at 9. Okay, and then I'm saying let me draw another graph, and then still draw, and then still touching at 9, and then someone will say let me draw another graph, and then still draw, and if you check it's still touching at 9, and then like that. So if you have been asked about the domain and the range, remember, what did I say about the domain? Anyone who remembers? Guys, the time is not there anymore, so let's wrap up. Domain. What do we know about the domain?
I think you said it is the starting and the ending point of the x-axis.
Thank you. So we're looking on the x-axis. Where does the graph start? Where does it end? Like I explained now, if you check the what do you call this graph? The orange graph. If you check, it's still the same graph, by the way, but it can be extended anyhow. So if we focus on the orange graph, we don't know where does it start because it starts somewhere there on the left hand side. We don't know where does it end because it ends somewhere there on the right hand side. We don't know where. For the fact that we don't know where does it start, where does it end, we are going to say the x is the element of real numbers. I explained that on the straight line. Why did I say element of real numbers? We don't know where does it start, we don't know where does it end. So that's why we include every value that we know. X element of real numbers, or you can say starting from negative numbers to positive numbers. That is negative infinity to positive infinity. But what if I'm talking about the domain? I mean the range, sorry, range. If I have to draw this graph, can I draw this graph somewhere here? No. Why? Because I can't move at this point. I don't know. I'm only limited by this point. I can go draw the graph. It can go up, 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 but it cannot go down. Why? It's limited by 9. So I can talk of any numbers on this line. I can talk about any numbers on this line on the y-axis, but I cannot talk about the numbers that are below this point. And remember, the numbers that are below this point, all of them, they are smaller than negative 9. So if for this one, you just say, I am limited by 9. I'm limited by negative 9. But where must I not go? Right? I must not go to the less than sign. Meaning, where are you going? You are going to all the values that are greater or equals to, oh, 9. Sorry guys, I wrote x instead of y. Range is y. Sorry for that, guys. Range is y. Y there. Y. Can I repeat that? That is y. Y is greater or equals to negative 9. If I was in my own class at school, I was going to say, please explain to someone. I was going just to pause and make sure that someone explains to someone what I'm saying. So I'm gonna pause because I'm gonna wait for a question here. We still looked for the x-intercept in Daweniga y sabegu 0. We looked for the y for the x-intercept. We looked for the y-intercept. In space of y we put 0. We looked for the x-intercept in Daweniga y sabegu 0. So we still do like that. And remember, we need to know what is the shape. Before you even draw, you need to know what is the shape. I'm gonna pause and wait for a question. Your question is not stupid, your question is not clever, you are not right, you are not wrong. Just say what you want to say. I'm listening, waiting for a question. That was the parabola graph that we were drawing there. You guys, I'm gonna give a homework whereby you're going to draw 2 graphs on one Cartesian plane. In this way, we'll be saying we're drawing 2 graphs on the same set of axes. We are going to draw 2 graphs on the same set of axes. I'm waiting for a question, by the way. Question? Okay. No question. Since there is no question, let's say if I'm saying draw on the same set of axes. If I was saying draw this one, where is this thing now? Oh, it's here. If I was saying this graph that we started with, I'm saying draw it on the same set of axes with this one that we're doing now. This one here. Then we were going to say, because that graph has got the point negative 3, has got the point y is equals to negative 3, and it's got another point that is x is positive 3 over 5. We were going to do it like this. We were going to do it like that. Done. We do the calculation for the first one, draw it, do the calculation for the second one, draw it. In that way, we are saying we're drawing the 2 graphs on the same set of axes. Now I know that all of you who attended here know how to draw a parabola. All of you who attended here know how to draw a straight line. Now, I want you to draw the two graphs on the same set of axes. I want you to draw the two graphs on the same set of axes. Since there is no question from you guys, this is what you're going to do. Mind you, I did put this on Facebook just in case you did miss the explanation somewhere somehow, so you can go there and check. Now, remember on my Facebook you can go and check it's Perusa Rapulana. Okay, you can go and check there, or you can use the link that I've sent you the other day with the other lesson that we did, and then we can use that. I just want you to draw this one. Y is equals to negative x squared plus 4. I want you to draw that one, and then also draw this one with this one also. Y is equals to 2x plus 4, and then draw these graphs on the same set of axes. Basically, I'm trying to say draw on the same Cartesian plane. I don't want two different Cartesian plane. I want you to draw on one Cartesian plane. And from here, you guys will show me what you've drawn tomorrow. Because I've seen when I'm saying send it to me to check, you don't. So you'll show me with the camera before we start tomorrow. You will switch on the camera and show me whatever that you did. Otherwise, I'm done. Thank you. I'll send you the time for tomorrow. What time do we meet? And then from here, I'm done, and that would be your homework. Thank you for your time. Bye bye. Till we meet again tomorrow. Wait. Yeah, on Facebook, you also draw that, and then you can ask whoever that you're asking. If you know my number, you can ask me, but no problem, you can ask whoever that you're asking. So draw that on the same set of axes. We'll be continuing with that tomorrow. Thank you for your time. Thank you for joining us on Facebook. Bye bye. Bye.